In this video, we're going to graph rational functions from section 3.6. So we're going to start by factoring this denominator. And we're going to look at both forms here. But first thing is to get it in factored form over x plus 6 times x minus 6. The domain is going to be negative infinity to negative 6 union negative 6 to 6 union 6 to infinity. There's nothing different here. R is already in lowest terms. None of the factors cancel. Locate any intercepts. No x-intercepts because the numerator can never be equal to 0. So my y-intercept is going to be when x is 0 here. Y is going to be 5 over negative 36. So the graph has a y-intercept of 0, negative 5 over 36, and no x-intercepts. Determine the behavior of the graph R at any x-intercepts. There are no x-intercepts. Determine the vertical asymptotes. There are 2 vertical asymptotes. X equals negative 6 and x equals 6. Determine any holes. There are no holes because there were no factors that canceled out. So on either side of the vertical asymptote. So let's go something a little bit more negative than negative 6 here. That would be a positive over a negative times a negative is going to be a positive. So it's going to go off towards positive infinity. So it approaches positive infinity from the left. And then as I get close to negative 6 from the right, this part changes signs and is positive. So that's going to be a positive over positive times negative is negative. So it's positive infinity from the left, negative infinity from the right. Where'd that go? It approaches positive infinity on one side of the asymptote and negative infinity on the other side of the asymptote. And then this is negative 6 and 6 for the asymptotes here. Does the same thing here, negative 6 and 6. There we go. If we would check here and see the behavior as I get close to 6 from the left, this is negative here, and this is positive, and this is positive, giving me negative infinity. Negative 6 from the right is positive, 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 gives me positive infinity. Inspect that with your graphing calculator if you need to see what happens on both sides of those asymptotes. Or you can make a table, whichever way your teacher shows you to do that. Determine the horizontal asymptote, if any. It has a horizontal asymptote at y equals 0 because degree of the top is less than degree of the bottom. And there's no oblique asymptote. And then determine the points, if any, in which the graph intersects the horizontal or oblique asymptote. Is that ever equal to 0? It is not, so there's none. There's no point in which the graph intersects the horizontal or oblique asymptote. use the real zeros of the numerator and denominator to divide x-axis into intervals and determine where it is above or below. So the graph is, let's just look here, that we have asymptotes at -6 and at 6 here, and that we said that it was when we were smaller than -6 here, it was negative, and negative is positive. So it was positive, which is above. And then over here, as we got slightly bigger than -6, it was negative. So it was below the x-axis. And then to the right over here, it was positive, it was above. And so we have B, the graph is above from -infinity to -6, union 6 to infinity, and it's below from -6 to 6. So which one of these looks correct there? That looks like B is below the x-axis from -6 to 6 and is above from -infinity to -6. Also has that horizontal asymptote of y = 0 that we talked about. That never crosses it. Right? Let's go ahead and look at the next one here. Let's write it in factored form. This is x squared over x plus 3 times x minus 2. That gives me zeros of my denominator at -3 and 2. So my domain is going to be -infinity to -3, union -3 to 2, union 2 to infinity. There are no factors that cancel, so it's in lowest terms already. The graph is going to have an x-intercept at 0, 0, which is also going to be its y-intercept. So this is 0 and 0 here. They just want the x-coordinate and the y-coordinate for the intercepts. They don't want ordered pairs. Determine the behavior of the graph of R at any x-intercept. So for instance, is it going to touch across? So it's going to touch at the x-intercept there because it has an even multiplicity. So the graph will touch the x-axis at x equals 0. Determine vertical asymptotes. Those are going to be at x equals -3 and x equals 2. And then no holes because didn't have any factors that canceled out. And these have odd multiplicities here, so it's going to do different things on each side. It's going to switch sign as it crosses the asymptote. So it's going to approach positive infinity on one side and negative infinity on the other. So that's going to be C. And those asymptotes again are at -3 and 2. Horizontal asymptote, too far there. Degree of top and degree of the bottom match each other. So look at the leading coefficients here. 1/1 is 1. That's one horizontal asymptote at y equals 1. That means that there's no oblique asymptote since there's a horizontal asymptote. And is this function ever going to be equal to 1? Let's see. So is x squared over x squared plus x minus 6, is it ever equal to 1? That would mean x squared needs to be equal to x squared plus x minus 6. So x would be equal to 6. So yes, plug 6 back in, and we get 36 over 9 times 4. That's 4 over 4. That's 1. So 6, 1 is where it's going to cross. Crosses at 6, 1. And now let's look at the vertical asymptotes and zeros. Here, this was -3 and 2. And these are asymptotes, and that's a 0. And I stick in a number like -4. That's going to give me positive, negative, negative. That's going to be a positive. When I stick in a number like -1, that's going to be positive, positive, negative. It's going to be a negative. When I stick in a number like +1, that's going to be positive, positive, negative. It's going to be negative. And when I stick in a number like a +3, that's going to be positive, positive, positive. Is positive. And that's exactly what I expected. I expected no sign change at the 0 because it touches there, but I expected sign changes at the asymptotes here. So the graph of R is above the x-axis on the intervals from -∞ to -3, union 2 to infinity, and it's below on the intervals from -3 to 0, union 0 to 2. And going to have a portion that's above, then a portion that's below, then it hits 0, then another portion that's below, then a portion that's above. That looks like B to me. Everything else matches, and you can see that it does cross at, where did we say, 6, 1 over here. It's kind of hard to see, but it's going to cross over here, and then it's going to approach the horizontal asymptote from the bottom. So watch out for that if you're drawing that by hand. All right. Now let's factor this one. We need to factor both the numerator and denominator this time. This is going to be x minus 6 and x plus 2 and x and 48, 6 and 8. So plus 8 minus 6 gives me +2. And we're going to have this factor here cancel in a minute, but not yet. So this is going to be x minus 8, x minus 6 over x minus 6, x plus 2. And the domain is going to be x can't be -2 or 6. But can be everything else. That's -infinity to -2, union -2 to 6, union 6 to infinity. Now in lowest terms, this is going to be x plus 8 over x plus 2. Once I cancel out that common factor, remember though, don't change the domain. The only x-intercept is going to come from the piece of the numerator that remains after I simplify. So that is going to have one x-intercept at -8. And the y-intercept is going to be 8 over 2 is going to be 4. And we already said it's going to cross at, or it's going to, yes, cross at -8 because it has an odd multiplicity. There we go. And vertical asymptote will be at x equals -2. So one vertical asymptote, x equals a -2. There is going to be a hole in the graph at x equals 6. And we'll have to plug that 6 back into the simplified form to see what the y coordinate would be. That would be 14 over 8 is 7 over 4. So 6, 7/4 is where my hole is. And then determine the behavior of the graph on each side of the asymptote. So since it has an odd multiplicity, it's going to approach opposite signs of infinity. So that is going to be B. And that vertical asymptote is at -2. Determine the horizontal asymptote. That's going to be, since it's x over x here, 1 over 1 is 1. And no oblique asymptote since it has a horizontal asymptote. And does it ever intersect its horizontal asymptote? Let's see here. Is x plus 8 over x plus 2, does that ever equal 1? Is x plus 8 ever equal to x plus 2? Does 8 ever equal to 2? No, it does not, so it's never going to cross. There's no point where it crosses the horizontal or oblique asymptote. Now we're going to be interested in -2 and -8. So -8 is my x-intercept, -2 is my asymptote, and that's it. So I'm not worried about my hole because that's clearly going to be above or below. So Negative over a negative is going to be a positive here. So that's going to be above. And then so let me, yeah. And then from -8 to -2, it's going to change sign. It's going to be below. And then from -2 to infinity, it's going to change sign again. It's going to be above. Don't forget that there is this point over here at 6 that's not defined, but it's still going to be above up there. So the graph is above the x-axis on the intervals from -infinity to 8, union -2 to infinity, and it's below from -8 to -2, like that. And so we're going to start off above, and this is going to be kind of hard to see, but it's above. It's going to cross the x-axis. It's going to go below. Then on the other side of -2, it's going to be above. It's got that hole at 6. So this is A. Got another question here. And this one is degree of the top bigger than the degree of the bottom. So we potentially have a oblique asymptote here. Let's factor my numerator completely. 7. It's going to be x plus 7, x plus 4. Over x plus 7. When I simplify it, it just simplifies down into x plus 4. Domain is that x can't be equal to -7. So -infinity to -7, union -7 to infinity. X-intercept will be at -4, and y-intercept at +4, -4 and 4. Then the graph will cross the x-axis at x equals -4. It's going to cross because that factor has an odd multiplicity. Vertical asymptotes, there will be none. And determine the hole, if any. There is a hole at x equals -7, where that factor canceled out, and -7 plus 4 is a -3. And then it did not have any vertical asymptotes, so that's it. And it's not going to have a horizontal asymptote either, because there's no bottom left to have a degree at the bottom. Also, it's not horizontal, it's slanted, what's left. Now, because what's remaining doesn't look rational, it's just linear with a hole in it. There's actually no oblique asymptote left either. I'd only be interested in that if there was a top and a bottom and the bottom still divided into the top evenly, but we don't have that here. So there was no horizontal or oblique asymptote, so we can't have a point of intersection, and the x-intercept was at -7. Well, that's where the hole is. I'm sorry, is at -4. So -4 is where the x-intercept is. There's a 0 over here at -7, but don't worry about that. -4 is what I'm interested in. So to the left of that, I'm negative, and to the right of that, I'm positive. So this is below and above the x-axis here, -4, and it's going to look linear. So it's not this and not like that. And it looks like x plus 4, so it's going to have a positive slope. So it's like that, not like that, because that has a negative slope. And you can't see the hole there, but I promise you that it is right there at -7, and the x-intercept is right there at -4. All right, that's it for this video. We'll come back next time and we will talk about section 3.7. See you for the next video.